Good morning, children. Today we are going to start Chapter 1 Number System of Class 9th NCERT. As the name of chapter indicates number system, so we talk about numbers here. Introduction. Numbers play an important role in our life. We see numbers on clocks, denominations, etc., and also use them in many ways. In your earlier classes, you have learned about number line and how to represent different numbers on number line. So first of all, you should know about these, or we will recall what you have already learned in your previous classes. We will recall different types of numbers first. So the first type is natural numbers. As you know, these are simple counting numbers, for example 1, 2, 3 up to infinity, and are denoted by capital N. Smallest natural number is 1 and greatest natural number is infinity. So there is no greatest natural number. So N is a set of natural numbers 1, 2, 3 up to infinity. Next comes whole numbers. Natural numbers including 0 forms the collection of whole numbers. For example 0, 1, 2, 3 up to infinity, and they are denoted by capital W. So W is the set of whole numbers 0, 1, 2, 3 up to infinity. Smallest whole number is 0 and greatest is infinity. Next category is integers. Integers are whole numbers and the negative of whole numbers greater than 0. That is 0, 1, 2, 3 up to infinity, and 0, minus 1, minus 2, minus 3 up to infinity. So you can see 1, 2, 3 up to infinity, they are positive integers, and minus 1, minus 2, minus 3 up to infinity, they are negative integers. And 0 is neither negative nor positive integer. So integers are represented by capital Z. So capital Z represent the collection of all integers. Positive integers are represented on the number line by the points on the right hand side of 0, and negative integers are represented on the number line by the points on the left hand side of 0. So you can see from here, see on the right hand side, you can see on the right hand side of 0 the numbers lies are 1, 2, 3 up to infinity. So that's why they are positive integers, and negative integers, they lie on the left side of 0, minus 1, minus 2, minus 3 and so on. So this is the concept. Now there are some more numbers still left on the number line, isn't it so? For example 1 by 2, 3 by 4, minus 2, 1005 by 2006. There are so many such numbers. Collection of such numbers are called rational numbers. Any number that can be expressed in the form P upon Q, where P and Q are integers and Q is not equal to 0, is called a rational number. Q should not be equal to 0. Q and the rational numbers are represented by capital Q. For example, 1 by 2 is a rational number because it is of the form P upon Q. 1 is an integer, 2 is an integer, so that is why 1 upon 2 is a rational number. Similarly, one more example, minus 3 by 4. Minus 3 is a negative integer, 4 is a positive integer. So minus 3 by 4 becomes a rational number because it is of the form P upon Q, where P and Q both are integers. Now we can take one more example. Minus 25 is a negative integer, but we can write it in the form minus 25 by 1 because it is of the form, now it is of the form P upon Q. So it becomes a rational number. So therefore the rational number also includes the natural numbers, whole numbers and integers. For example, we can take an example of a whole number 2 or a natural number 2. We can write it in the form of 2 by 1 P upon Q form. So it is also a rational number. Next is representation of rational numbers on a number line. You have already learned about how to represent the rational numbers on number line in your previous class, chapter 1 rational numbers, exercise 1.2. Now you know, between two given rational numbers A and B, there exist infinitely many rational numbers. For example, question is write 3 rational numbers between 3 by 5 and 2 by 3. So we are writing it in the form 3 by 5 and 2 by 3. So the method is, first we have to make the denominators like. So here the denominator is 3 and here the denominator is 5. So first of all we'll multiply it by 3 by 3, the denominator of other number, and this number will be multiplied by the denominator of first number, 5 by 5. So it becomes 3 into 3, 9, and 5 3s are 15, 9 by 15, and it becomes 2 into 5, 10, and 3 into 5, 15, 10 by 15. Now you can see between 9 and 10 there is no number. No number lies between 9 and 10. So what we have to do is we can multiply one by it with bigger number. So we are multiplying it by 10 by 10. 9 by 15 into 10 by 10, and 10 by 15 into 10 by 10. So you get 90 by 150 and 100 by 150. Now you get enough numbers between 90 and 100. So it will be written as 90 by 150, 91 by 150, 92 by 150, 93 by 150, 94 by 150, 95 by 150, and so on till 100 by 150. So we require 3 rational numbers. We can find out these 3 rational numbers are the required numbers. So likewise, if we want to find 10 rational numbers, we can multiply by bigger number. We can multiply by 20 by 20, 30 by 30. As many numbers we want, we can multiply it by the bigger number. So we can take an example now. This is example 1 of chapter 1. Are the following statements true or false? Give reasons for your answers. Every whole number is a natural number? False. This statement is false. Every whole number is a natural number? No, this is not true. 0 is a whole number, but it is not a natural number. So that's why it is false. Next is, every integer is a rational number? True. This is true. Because every integer m can be expressed in the form m by 1, and so it is a rational number. We can take another example. Suppose minus 2 is an integer, and we can write it in the form minus 2 by 1 to make it a rational number. So yes, every integer is a rational number. Third is, every rational number is an integer? False. The statement is false because 3 by 5, we can take an example of 3 by 5. It is a rational number, but it is not an integer. So next example is, find 5 rational numbers between 1 and 2. So you can do this sum as you have already done this concept in your previous class. So you can try out this example yourself. So come to exercise 1.1 now. Is 0 a rational number? Can you write it in the form p upon q, where p and q are integers and q is not equal to 0? So the solution of this question is yes, 0 is a rational number. We can write it in the form p upon q, because we can write 0 in the form of 0 by 1 or 0 by 2 or 0 by 100 and so on. So here both p and q are integers and q is not equal to 0. The denominator should not be equal to 0. So this was question 1. Yes, 0 is a rational number. Second is, find 6 rational numbers between 3 and 4. So I'll be doing this part. Third question you will be doing it yourself. So I'm doing second question. Find 6 rational numbers between 3 and 4. So the numbers are 3 and 4. So first of all, we have to write it in the rational number form, 3 by 1 and 4 by 1. So we can multiply. We need 6 rational numbers. So we can multiply it with one bigger number, 10 by 10, with both the numbers, 3 by 1 into 10 by 10 and 4 by 1 into 10 by 10. You get 30 by 10 and 40 by 10. So 30 by 10, between 30 by 10 and 40 by 10, the number lies are 31 by 10, 32 by 10, 33 by 10, 34 by 10, 35 by 10, 36 by 10, and so on. So we need 6. We got these 6 rational numbers. If you want more, you will multiply. You can multiply with one more, with bigger number, 20 by 20, 15 by 15, any number you can multiply. The more you will take the bigger number, you will get the more and more numbers. So question number 3 now is, find 5 rational numbers between 3 by 5 and 4 by 5. So I hope you can try this sum yourself. So we'll come to next question. Question number 4. State whether the following statements are true or false. Give reasons for your answers. Every natural number is a whole number. The question is, every natural number is a whole number. True, because collection of whole numbers contains all natural number. Yes, because 1, 2, 3, they are natural number as well as they are whole number. So yes, every natural number is a whole number. Now, next comes second part is every integer is a whole number. So this statement is false. Minus 3 is an integer. We are taking an example of minus 3. It is an integer. But it is not a whole number. Minus 3 is integer, but minus 3 is not a whole number. Whole numbers are never negative. So this statement is false. Now come to third part. Every rational number is a whole number. So the statement is again false. 1 by 2 is a rational number, but it is not a whole number. Every whole number is a rational number, but every rational number cannot be a whole number. So this statement is again a false statement. So this completes your exercise 1.1. Thank you.